Hello students, I hope you all are fine. So today we are going to start one new unit, that is the equilibrium. Okay, students, equilibrium. You know, equilibrium we can attain physical equilibrium also, chemical equilibrium also. If I talk about physical equilibrium, you know very well, in physical equilibrium, what phase transformation can take place? Physical state means solid can convert into liquid. Liquid can convert into gas. Solid can convert into the gas. Reverse processes also can take place. Here, solid can convert into liquid, but liquid can also convert into solid. Liquid in gas, gas in liquid, these. Means phase we can transform from one to other. Okay. Now what is the equilibrium? Students, if I talk about this one, here solid convert into liquid. That is known as the fusion. That is known as the fusion. That process is known as the fusion or melting. Clear? And if liquid convert into the solid, then it is known as the solidification. If I say concentration of the solid, amount of solid, concentration, or we can say amount, concentration of solid and liquid, both become constant, they become equal. Then we can say they are in equilibrium. How does it may happen, students? If I am having a closed container, it is totally insulated. It is totally insulated. Means heat transfer not take place here. Here change in heat. In thermodynamics, you have studied about that. It is totally insulated. Okay. Then change in heat is zero. Heat neither entering nor it is going outside. Here students, we are having some ice and some liquid also, means some water also we are having. Some water we are also having here. And students, here we are having fixed temperature. Standard temperature means temperature is fixed because heat is not entering, not going outside. So temperature is constant here. Pressure also constant. Pressure also we are taking constant. Then students, at least some temperature they are having. So here this solid is converting into liquid also. And this liquid is also converting into solid. But their rate, here rate of fusion and rate of solidification, that is equal. That is equal. Means दोनों ही जिस रेट से ये हमारा जो आइस है ये किस में, जो सॉलिड लिक्विड में कन्वर्ट हो रहा है, साथ साथ में उसी रेट से लिक्विड में किस में कन्वर्ट हो रहा है, सॉलिड में. तो जो टोटल सॉलिड की कंसंट्रेशन वहां पर है और जो टोटल लिक्विड की कंसंट्रेशन वहां पर है वो क्या है, कांस्टेंट. वो क्या है, कांस्टेंट। देखो ये हमारा एक डायनामिक इक्विलिब्रियम है, हम ये नहीं कह सकते कि ये सॉलिड इसमें कन्वर्ट नहीं हो रहा या लिक्विड इसमें कन्वर्ट नहीं हो रहा, यहां पर चीजें डायनामिक हैं। इट इज द डायनामिक इक्विलिब्रियम। Solid is also converting into liquid. Liquid is also converting into solid. But rate of conversion is constant. That is equal. Rate of conversion is equal. Rate of fusion is equal to rate of the solidification. That's why concentration of the solid and concentration of liquid is constant there. It is not going to be changed. Clear? Process is dynamic. They are continuous process, but there is no effect in the concentration of both. That is constant. That's why we are saying in equilibrium. So this type of the equilibrium is known as the dynamic equilibrium. Any doubt in this one? Clear? Okay, so in equilibrium cases, temperature will be constant, pressure will also be constant, and students, here rate of forward reaction, we can say, means rate of the forward process, the here process is going on in this direction also, and in this direction also liquid is also converting into solid. So both rate of forward process and backward, both should be same. Both should be same. And concentration, here we can consider this one reactants here. This one means which we are getting final, means their concentration also constant there. Clear or not? Here only physical, only state transformation take place. That's why we are saying these are the physical equilibrium. Clear? Like this, liquid can convert into the gas. This process is known as the evaporation. This is known as the evaporation. And gas convert into liquid. That is known as the condensation. Means if rate of evaporation is equal to rate of the condensation, that it is also equilibrium, physical equilibrium. Solid into gas, sublimation. Conversion of solid into liquid, sublimation. And gas into solid, deposition. Means if rate of rate of sublimation and deposition is equal, then also in equilibrium. Means these are the examples of the physical equilibrium. Here phase transformation take place. Clear or not? But rate of forward as well as backward, it will be the same. Clear or not? Any doubt in this one? Now, chemical equilibrium can also take place, students. Chemical equilibrium. Chemical reaction. In chemical reactions, what will happen? Reactant will convert into the product. Clear? Let us consider we are having reactants A and B. A and B. They are going to be convert in C and D. But students, this C plus D also converting into A plus B, means reaction is taking place in both direction. In forward direction, when reactants are converting into product. Forward direction, when product further convert into the backward direction. Okay, reaction may be forward and backward. Okay, so students, here what should be? Concentration of reactants and concentration of products it should be constant. It should be constant. Means there is not going to be change. Students, try to understand what will happen. Let us consider in starting, here this is the time, this is the concentration. In starting, students, I am having reactants only, not product. Like I want to set curd. So in starting, I am having milk only. Here product is 0. Clear? Then I will add some source substances like some amount of curd into that. Then these particles will start to react with each other, and after some time they will react with each other, and setting of curd will start, and after 3 or 4 hours completely we will get curd. Now means at starting our reactant is maximum, our reactant in maximum amount, but product is 0. Product is 0 means when time 0, when time 0 means reaction not started, reaction not started till now. So at this time we are having reactants only and our product is 0. But students, if reaction will start, means according to time reactants will react with each other. They will, after reaction, continuously reactant will react with each other and they will produce products. They will produce products. So in reaction mixture, reactants concentration decreases according to time. Concentration of reactants डिक्रीजेज. स्टार्टिंग में केवल आपके पास मिल्क था, बट धीरे धीरे क्या हुआ, मिल्क की कंसंट्रेशन आपके पास क्या हुई, डिक्रीज. बट वो किस में कन्वर्ट करना स्टार्ट कर दिया उसने, कर्ड में. तो कर्ड जो मीन्स कर्ड क्या था आपका, प्रोडक्ट. तो प्रोडक्ट की कंसंट्रेशन फिर धीरे धीरे टाइम के अकॉर्डिंग जब आपस में रिएक्ट करेंगे रिएक्टेंट्स, तो वो क्या होगी, इंक्रीज होगी. ठीक है. एक टाइम पर क्या होगा कि ये जो हमारी प्रोडक्ट की जो कंसंट्रेशन है और जो हमारी कंसंट्रेशन ऑफ रिएक्टेंट है, ये दोनों क्या हो जाएंगी, कांस्टेंट. ये दोनों क्या हो जाएंगी, कांस्टेंट. मींस इसका मतलब क्या है, या तो ये हो सकता है कि रिएक्टेंट्स ने कंप्लीटली जितना ये मैक्सिमम रिएक्ट कर सकता था, इसने रिएक्टेंट्स ने उतना रिएक्ट कर लिया और उतना प्रोडक्ट हमें दे दिया. अब जो हमारा रिएक्टेंट है उसकी नेग्लिजिबल कंसंट्रेशन हमारे पास है, जिससे वो फर्दर रिएक्ट नहीं कर रहा, जिससे हमारे पास अब प्रोडक्ट का जो अमाउंट है वो क्या है, इक्विलिब्रियम मींस ए कांस्टेंट अमाउंट है. क्लियर और नोट. या तो ऐसा हो सकता है कि जितना इसने मैक्सिमम रिएक्ट करना था रिएक्टेंट्स ने आपस में, उतना इन्होंने रिएक्ट किया. क्लियर. तो अब हमारे पास लेकिन ये नहीं है कि उसने मीन्स कंप्लीटली, देखो बेटा एक 100% डिसोसिएशन होता है, मीन्स जितना रिएक्टेंट हमारे पास था 100% हमें प्रोडक्ट मिला, बट हर रिएक्शन में 100% हमें नहीं मिलता, वो उसके रेट ऑफ डिसोसिएशन पर डिपेंड करता है. क्लियर. तो रिएक्शंस में हम देखेंगे कुछ रिएक्शंस ऐसी होती हैं कि हमारा जो प्रोडक्ट है ये दोबारा इक्विलिब्रियम में है. ठीक है. तो जिस टाइम पर इन दोनों की कंसंट्रेशन जो हमारी वो क्या है, इक्वल हो जाती हैं, एक कांस्टेंट हो जाती हैं, फर्दर चेंजेस उनमें नहीं आते, तो उसको हम क्या बोलते हैं, इक्विलिब्रियम. क्या बोलेंगे, इक्विलिब्रियम. क्लियर और नॉट, एनी डाउट इन दिस वन? क्लियर. देन students, chemical equilibrium in which concentration of reactant and concentration of product constant. या फिर ऐसे हो सकता है, या तो ये हो कि हमारा रिएक्टेंट जितना उसने मैक्सिमम रिएक्ट करना था उतना उसने रिएक्ट किया और हमें मैक्सिमम प्रोडक्ट मिल गया, फर्दर रिएक्शन की पॉसिबिलिटी नहीं है रिएक्टेंट्स के बीच में, जिससे फर्दर हमें प्रोडक्ट नहीं मिल रहा. अब दोनों की कंसंट्रेशन हमारे पास क्या है, कांस्टेंट्स है. ओके, that may be the chemical equilibrium. बट सेकेंड पॉसिबिलिटी ये भी तो हो सकती है कि भाई जिस रेट से फॉरवर्ड मीन्स जो रेट ऑफ फॉरवर्ड रिएक्शन है, रेट ऑफ फॉरवर्ड रिएक्शन है वो इक्वल है रेट ऑफ बैकवर्ड रिएक्शन के. रेट ऑफ बैकवर्ड रिएक्शन मीन्स जिस रेट से ये रिएक्टेंट्स आपस में रिएक्ट होकर हमें प्रोडक्ट प्रोवाइड करते हैं, उसी रेट में ये फर्दर प्रोडक्ट साथ साथ में ये जो प्रोडक्ट्स हैं वो दोनों आपस में रिएक्ट करके हमें क्या दे रहे हैं, रिएक्टेंट्स। तो वहां पर भी क्या होगी, क्योंकि जिस रेट से ये इसमें कन्वर्ट हुए सेम रेट से ये भी इसमें कन्वर्ट हो रहे हैं, तो वहां पर भी दोनों की कंसंट्रेशन क्या रहेगी, कांस्टेंट रहेगी। क्लियर। सो सेकंड कंडीशन में भी रेट ऑफ द फॉरवर्ड रिएक्शन इज इक्वल टू द रेट ऑफ द बैकवर्ड रिएक्शन। क्लियर और नॉट? सो दिस मे बी द कंडीशंस, yes or not? Then students, some chemist gives us relationship between concentration of reactants and products. What is the relationship between concentration of the reactants and products at equilibrium? First, at equilibrium, rate of forward reaction, most common condition is rate of forward reaction is equal to rate of backward reaction. कई बार आपने देखा होगा कहीं पर कि हम अगर पानी, मतलब पानी तो उसमें गिरता है, कई बार आप जैसे किसी साइंस सिटी में या फिर ऐसे अगर घूमने जाते हो तो वहां आपका क्या होता है कि भाई पानी ऐसे साथ में, मीन्स किसी पॉन्ड में आप पानी क्या कर रहे हो, इनलेट कर रहे हो, डाल रहे हो, बट यहाँ पे लेवल इंक्रीज नहीं हो रहा, ऐसा होता है। तो वो उसमें एक ऐसी मतलब फंक्शनिंग होती है जिस रेट से वो उसको इनलेट कर रहे हैं ना, नीचे कोई ऐसा कि सेम रेट से वो क्या हो रहा है, आउटलेट भी, जिससे हमें ये इक्विलिब्रियम में दिखाई देता है। यहाँ कंसंट्रेशन में कोई वो नहीं देखा है, कहीं पे देखा है? चलो, हमारे पास एक टंकी है पानी का टैंक है। पानी में हमने क्या करना है, यहाँ एक टैप लगाया है जिससे हम इसमें कंटिन्यू पानी डाल रहे हैं। एक यहाँ सेम, यहाँ भी हमने क्या लगाया है, एक टैप आउटलेट, इससे हम पानी क्या कर रहे हैं, निकाल रहे हैं। दोनों में से सेम रेट से क्या होगा, मान लो आपका टैंक इधर तक पहले से ही भरा हुआ है, क्या होगा, क्या इसके लेवल पे कोई इफेक्ट आएगा? क्यों? क्योंकि जितना पानी आप ऊपर से इसमें ऐड ऑन कर रहे हो उतना ही पानी आप साथ साथ में निकाल भी रहे हो। तो ये क्या है, इक्विलिब्रियम। क्या है, इक्विलिब्रियम। क्लियर? तो दिस वन इक्विलिब्रियम। यहां भी वही है, जिस रेट से ये रिएक्टेंट्स प्रोडक्ट में कन्वर्ट हुए हैं, सेम रेट से प्रोडक्ट भी किस में कन्वर्ट हुए हैं, रिएक्टेंट्स में। सो रेट ऑफ फॉरवर्ड इक्वल टू रेट ऑफ द बैकवर्ड रिएक्शन, दैट इज नोन एज द इक्विलिब्रियम। नाउ व्हाट इज द रिलेशनशिप between this concentration? Here student, one constant there, that is known as the equilibrium constant. Backward, there is one equilibrium constant. This will be equal to the product of the concentration of product. Here product is C and product is D. Product of the concentration of product divided by product of the concentration of reactants. One product mean multiplication, okay, and one product mean products here, okay. So here equilibrium constant is equal to the product of the concentration of product divided by product of the concentration of reactants. This will be the relationship between concentrations of the reactant and product. And student, this is known as the law of chemical combination. According to the law of chemical combination, equilibrium constant is equal to the product of the concentration of product divided by product of the concentration of the reactant. Clear or not? Like this. If I have sodium nitrogen plus hydrogen, you know very well, they produce ammonia by Haber process. And here students, this reaction is equilibrium reaction. Here also equilibria take place. So first of all we will balance this one, 3 and 2. It is balanced equation. Now how can we write equilibrium constant for them? How can we define law of equilibrium for that? Clear? If students, your reaction is like this, means if stoichiometric coefficients are here, if you balance the reaction, then 1, 2, 3, these are known as the stoichiometric coefficients. Stoichiometric coefficients. Then how can we write equilibrium constant? Then equilibrium constant is equal to the product of concentration of product. Here product C and product D. Product of the concentration of the product is raised to power their stoichiometric coefficient. Is raised to power. This C stoichiometric coefficient is small c. So we will keep this in power of this. Clear or not? Then this D, this is the reactant. Its coefficient is small d. So put this in power of this one. So stoichiometric here equilibrium constant is equal to the product of concentration of products each raised to power of its stoichiometric coefficient divided by product of reactants, and they also raised to power their stoichiometric coefficient. So its coefficient is A and its coefficient is small b. Okay, so in this way, always students, we will write concentration. Concentration, you will also write in concentration. Always you will write in square brackets. In square brackets. Clear or not? Like this one, concentration of C. I have written in square bracket. It shows it is concentration. Clear or not? Yes. So for this one, if I want to write stoichiometric of, if for this one, I want to write equilibrium constant. So how can we write? K. Equilibrium constant we can show with Kc also. We can represent with also Kc. It will be equal to concentration, product of concentration of product, but here only one product. That is ammonia. If we are writing concentration, then we will write in square brackets. Raised to power its stoichiometric coefficient divided by reactant. Reactant is N2 and its coefficient 1. So we need not to write power here. Then second H2. Its power is 3. So in this way we can write the equilibrium constant. Hence students, equilibrium is that in which rate of forward reaction is equal to the rate of the backward reaction. Okay, these reactions, in these reactions, reactants and product concentrations have some constant between them, means they have some relation. So what is the relation we can show with equilibrium constant, and this one is known as the law of chemical combination. Clear or not? Any doubt in this one? Okay, so what are the characteristics of the equilibrium constants? Other thing, today introduction part we have covered, so tomorrow we will discuss about that. Thank you, have a nice day.